Hello everyone, in this video I am going to talk about the project that we developed using convolutional neural network, which is a class of deep neural network, and also using transfer learning for traffic sign recognition and classification. This project is developed in Python, and the dataset which we used for this project is the German traffic sign recognition benchmark, which has more than 50,000 images and 43 categories that which we will be using each category as a label for training the model. And we have 4 files in this project. The first one is the traffic.py, in which we loaded all our data and resized the images and encoded all the labels. And we created our sequential model in here. And also we split our data into 40% of test data and 60% of training data, which we will train our model with the training data and test the model with the test set. And here we can see that the data were loaded, and this is the architecture of our model, which we have 3 convolutional layers and 3 max pooling layers for each convolutional layer, which is used for decreasing the spatial dimension of the convolutional layers. And also we have a flattened layer and a dense layer, which is the output layer with the 43 number of classes, and we have these parameters and weights. And then we start training our model with 10 epochs, and each epoch we can see that the accuracy is increasing and the loss is decreasing, and at the final we gain the accuracy of 97%. If we see the result, we can see something like this, that this is the accuracy, which in each epoch is increasing, and this is our loss, that is started from 2.5 and it decreased until 0.2 and 0.1. This was about the traffic.py file, and also in the second step we created a file named learn sign py, and this file for making our model fast, and also for adding some TensorFlow callbacks. We split our data set into 3 sets: the training set, the test set, and the validation set. We train our data with the training set and then validate it with the validation, and finally we train it, we test it with evaluate it with the test sets. So the 3 callbacks which we added in this file is the early stopping callback, which we add this callback to avoid overfitting during the data training. And also by using this callback, the training stops when there is no improvement in the monitored matrix, where we set the monitor matrix to the validation loss. And also we added a model checkpoint layer while training the data to save a model at some interval, and then we will be able to use it whenever we want, and this will be used only, this will save only the best models which are in here, and we can use it without any compiling the model or again and again. So we just call one of them. And also we used a TensorBoard callback that we want to log events for TensorBoard in the logs directory, and it enables the visualization of the TensorBoard. Then we fit our model with the training data, and we will train the model. Let's see the result, and this is the result which we will get. We can see that this is the loss of our model, which starts from 2 and stopped in here. we can see the results in here that in the epoch 5 the training is stopped because we use the early stopping callback. And also for the tensor board visualization, we just write the tensor board command and we can get the accuracy and the loss plots in the tensor board website, which is this is the accuracy that it shows the all information about it, that in every step it's increasing, and this is the loss that in every step is decreasing with the values and the time. And this was the second step of our work, and the third step we implemented the transfer learning. The transfer learning method is a popular method, especially in computer vision, because it allows to build accurate models in a time-saving way. How? That we can just use a pre-trained model. For example, this is one of my pre-trained model, and this is another which we created in these previous steps. So we load the model, and then we will create a new model on the top of this model, and after that we clone all the layer, we clone all the weights of this model into the new one, and but we freeze all the layers because we don't want that during the training the weights will be wrecked. And we get all the layers except the last layer, which is the dense layer, which in here it was with 43 classes, because in here we added 5 more classes because we wanted to implement the transfer learning. So now our classes is 48. So that's why we don't use the output layer. We will add our own output layer with the number of categories 48 and a softmax activation method. And then we say that we clone the model and freeze all the layers, and just we compile it, and with few iteration we will train this model. And after that we will set the model layers again. The trainable we will set true. It means that we will unfreeze the layers in order to train it with our new data. So this step is called fine-tuning the model. Now we are fine-tuning our model with the learning rate of this much. We will choose a smaller value of learning rate, and we will compile it, and after that we will train it with using the training data, and the result which we will get is let's see first the accuracy. So now we can see that only in 6 epochs we get the accuracy of 99%, which is quite enough, and also the loss is decreased to 0.2. And if we see the plots, in here is the plots. Usually the transfer learning starts from a very high value, and this way it decreases. This is the loss of both the training and validation sets, and this is the accuracy, which is going through 9.99% and more than 99%. So it was the implementation of the transfer learning. And the final step which we have done is now the testing of our model. So we will add our model, and in the recognize file we just added a dictionary for the labels which we had. Now we will go and run our recognize file. And here, this is the graphical user interface, which we created using tkinter package of Python, which is an object-oriented interface package. And now we want to test our model with some test data. For example, we are adding this, and the predicted class is general cautious. And if we choose another, and this is the predator, as we can see, this image is really blurred, so it's because it's the 99% of accuracy, so it can show it easily. And also the another successful try that result that we got. And let's now check the 5 other classes which we added and used transfer learning. For example, we used 5 classes of a Turkish traffic sign dataset. So this is a stop sign in Turkey, which predicted right. And also this is a no horn sign. And this is the street crossing route. And this was the project which we developed. And have a good time. Thank you.